Okay, in this video we're going to review how to find R values and find the equation of a line of regression on the calculator. So I've taken a question from the test review package and we'll just use that as our example here so we can see how to work on the calculator. So in this scenario, it's telling us about a number of bottles of water sold at a railway station on each day and the temperature on each of those days as well. So the first thing it's asking us for are the mean and the standard deviation of the temperature. So one thing you have to be mindful of is what the command term is. If the command term says write down, then you can just do this on your GDC. There's no need to show any work. You can just find it on the GDC and write down the answer in the space provided. So when we're attempting these statistics, the first thing we need to do is enter the data. So we're going to go Stat, Edit, and that will bring us to our lists. The temperature is the independent variable because it's in the higher row, so that's going to be our X values, and we're going to put those in L1. And number of bottles sold depends on temperature, so that's the Y values, and that will go in L2. So the first thing we're going to do is just enter all the data. So there we have the X values, and then we're going to go over to the next column for the Y values. Oh, 134 and then 141. Okay, so all of our data is entered. If we want statistics like mean and standard deviation, then for here, we're going to go to Stat, Calc, and you can do one of two things here. Because both of these are looking at temperature, we can do one variable stats only on L1, or we can do two variable stats and just look for the X data in that two variable stats analysis. So I'll show you both ways to do it. So Stat, Calc, first let's just do single variable stats. Here, you want to make sure that the list, so the data you're interested in is the X values, so that's in L1. We don't have a frequency here. There's no frequency for how often we have each temperature. We just have a list of temperatures. So we leave that blank. That's really important. Otherwise, you'll get inaccurate answers. So when you go to calculate, the mean is the X with the line over top. So that mean temperature rounded to 3 sig figs is 19.2 degrees. And that's rounded to 3 sig figs. And then the standard deviation is sigma x. So sigma x, or standard deviation of temperature, is approximately 1.45 to 3 sig figs. So that's one option. You can do one variable stats to find that information, or you can do the two variable stats and you'll get the exact same results. So I'll just show you quickly. This time, if we went to Stat Calc and we went to two variable stats, this time, because it's analyzing both the temperature and the number of bottles sold, we have to tell it what's in X and what's in Y. And again, there's no frequency. We have to leave that blank, otherwise we'll get incorrect results. So then if we go to calculate, it's going to give us all the same information for the X's, 19.2 and 1.45. The only difference is it also gives us the mean and the standard deviation for the Y. So if we needed to find both of those at the same time, two variable stats is the best option, but you don't have to do both of them. It's an either or. So either one of them will get you the correct response. So that's how you can find statistics like mean and standard deviation. Now the R value, when you're looking for the correlation coefficient, or the R value, sometimes you have to calculate it with an equation like this. So Sxy, the covariance of x and y, over the standard deviation of x times the standard deviation of y. But notice that this command term says write down. So we don't have to show any calculations, and we don't have all those pieces of information anyway. So what we can do is use a linear regression on the calculator. And the linear regression will give us the R value and will help us answer the later question about the equation of the line of regression. So since we already had to find the mean and standard deviation, we've already entered our data. We don't have to do that again. We can just go to Stat, Calc, and this time, instead of picking one or two variable stats, we're going to pick option 4, which is LinReg. That means linear regression. So anytime it asks you about the line of regression, just remember to look for LinReg. Now, before you do this, it's really important that you make sure your stat diagnostics are on, because if they're not on, you will not get the R value. You'll get the equation of the line of regression, but not the R value. So this is really, really important. The way you can check that is you can go to Mode and then just look for this line. So I'm going to go to Mode on my calculator, and now down at the bottom here it says Stat Diagnostics. That needs to be on. If you can't see Stat Diagnostics right away, if you scroll down this screen, it'll show up in the second screen. So that's good. I'm exactly where I want to be. So now I'm going to go back to Stat, Calc, and I'm going to pick option 4, which is LinReg. So again, I tell the calculator my x's are in L1, my y's are in L2, and again, I have no frequency. This has to be kept blank, otherwise you'll get the wrong answer. So I'm going to scroll down and go to Calculate, and it's going to give me 4 pieces of information. The values for the line of regression equation, an R squared value, which isn't important to me right now, and my R value. So I'm going to round my R value to 3 sig figs, 0.942, and that's rounded to 3 sig figs. And then I found my R value, and I'm going to keep that screen because I'm going to need it for the next, a later question. So when it's asking you to comment on your value for R, what it's looking for is type of correlation, so strong, weak, moderate, etc., and direction, so positive or negative. And a helpful resource for this is this image we had in one of our lessons. So our R value is 0.942. We would usually classify that as a strong correlation. And because it's positive, it'll be an upward trend, and we'll classify that as a strong positive correlation. So basically, an R value of 1 or -1 is perfect. In the area of sort of high 0.8 to 0.9 is strong or very strong. If you have anything sort of from 0.5 to 0.8-ish, it's considered moderate. And then anything below 0.5 is really considered weak. And anything sort of really close to 0 would be described as no correlation. So if we look at that table, we're really in the strong positive correlation area. So our answer to this question is just going to describe our R value as indicating a strong positive correlation. So the next question is to write down the slope or the coefficient for the equation of the line of regression. So that's the D value here. And you'll notice that since we had to find the R value, we've already got the equation of the line of regression. So the D value is the same as A, the way your calculator presents it. So D is equal to 11.5, rounded to 3 sig figs. And it's helpful to see that in this particular question, they won't always do this, they've given you the y-intercept, and since we got the same thing, that's a good sign. It means this analysis of the linear regression on the calculator is most likely correct. So once we have the equation of the line of best fit, we can use it to make predictions. So this question is asking us to estimate how many bottles of water will be sold when the temperature is 19.6. So we're going to solve for n, and we're going to sub in a value for temperature. And then what we can do is just calculate what we see there. So we have 11.5 times 19.6, and then we're going to subtract 100 from that. So our estimate, even though it's 125.4, we'd probably estimate that approximately 125 bottles will be sold on that day, because we can't really sell a fraction of a bottle. The last question is one that's seeking a bit of interpretation. So this one's giving us a scenario when the temperature was 36 degrees. Peter calculates that 314 bottles would be sold. And what they're looking for is an explanation or one reason why this answer might be unreliable. So if we look back at our data table, the maximum temperature available in our data is 21 degrees. So if we're making a prediction for a day when it's 36 degrees, that's a little tricky. So this data might be unreliable, because a prediction on a day when it's 36 degrees is considered extrapolation. So 36 degrees is outside the given range of data, and therefore it is considered extrapolation and is unreliable. So I hope this video has helped you figure out how to accurately find statistics, R values, and lines of best fit on the calculator.